Okay, welcome everyone to the July 2022 Zoom meeting of the mForth 2020 group. And we have some good talks ahead. And without much of additional words, I would like to give the stage to Peter Jakacki. He's talking about Fred, rapid embedded development for Mecrisp. And he will tell us about the new development on that area. So Peter, please go ahead.
All right. Thank you, Ulrich. Yeah, thank you everyone for being here. As I was saying earlier in the cafe, we're all enthusiasts, and we work at different levels, but we love what we do and we have real fun. I originally started out with hardware, just to give you a bit of background. With electronics, I really love digital electronics. I designed all these circuits, couldn't get the chips. And as I got older, I managed to, build things. And then microprocessors came along. Assembly language, BASIC, Fortran. These are the languages that we had. Then C came out. But about the same time, when I had that white book, K&R's white book on C, not really impressed with it. I discovered mForth on an Apple II. First thing I did with it was I used it to control the hard drive, to step it, move it around, diagnose problems, hardware, fault finding. And it's an interactive language. And you could get down to the bare metal. In BASIC, it was always a go-to here and a peek and poke. Terrible. You had to comment everything, and it was horrible. Anyway, that's a bit of my background. That's how I came into mForth, and I've been using mForth ever since in industrial, commercial projects and fun projects as well. Now we know we have the Pico, so the Raspberry Pi Pico, or the actual RP2040 chip, we should say, and that's a little chip there, and the board itself is the Pico, or the Raspberry Pi Pico to be more exact. And what I've done with that is I've ported my Tachyon, which I developed for the Parallax Propeller P1 and then the P2. Very powerful multi-core processors, but sometimes too powerful. I mean, I've got a chip that takes a lot of juice, has a lot of resources, but sometimes I just want a little tiny chip. And with 264K of RAM, that's the chip I wanted to use in a lot of projects. I designed a lot of hardware. Now, what I've done is I decided I'd put Tachyon across, but the assembler tools are terrible. So I thought, well, you know what? I'll learn about this chip with Mecrisp. Now, I put Mecrisp on it. I started to find out about the hardware, started to write all these words, and also decided I have a Tachyon compatibility layer, but everything's on there now, the FAT32, all the utilities, but still using Mecrisp as a kernel. There's some fundamental differences. We're talking about mForth. You've seen a mForth, you've seen a mForth. Okay, that's fine. But on top of Tachyon, the whole idea was, look, this is going to be my PC of the 80s. This is going to be my DOS and, all those beautiful tools that we had on the PCs back then to develop programs with. I'll write my own macro assembler for it. I'll write my own, editor and everything, and logic analyzer, all these different things. And that's exactly what I did. So Fred started off as an editor along with the other tools, but it's become the go-to place, the integrated development environment that's not on the PC, but on the chip. So what I'm going to do is I'm going to share a screen with my other computer over here. So I'll just do this. I'm going to share a terminal screen. So you don't have to look at me the whole time. And what are we going to do? I'll get the right one up here. Here we go. Let's get the right one over here. Got too many up here. Advanced, here we are. I'll get the actual portion of the screen, and I'm going to share a portion of the screen here now. So hopefully this is right. share. And how do I select this? This is always a problem, isn't it? Okay, share. Hopefully I can get this right. And if it's not right, well, I'll fix it up. Okay, it's not right. I'll use that portion of the screen over here. You can see that?
That works.
Okay, that's okay. That's good. I'll make that a bit larger. And I'll move everything into that if I have to, just so we can get down to the nuts and bolts. Terminal screen. This one here is Minicom running on Linux. And what I have here is I'm running at 921 and Mecrisp. So I'll just show you Mecrisp. I'll just get that. Mecrisp is there and it has its line feed problem, carriage turn line feed problem. And, you know, this is words. And it's great. It's ported across to the Pico. I can start working with it, but on Tachyon, it was really interactive. So what I've done is this. I'll reset that now. I'll reset it. I've added extensions to it. Let's blow that up a little bit. Perhaps you can see that a bit better. And there we go. I'll just do that. So what I've done is it starts up with Mecrisp, if you can read that there. And I'll try to do this right. And then I have my extensions loaded on. It's identified that what it's hooked up to a MakerPi Pico, which is, let's see if I can get this up here as well. There's a picture of the board that I've got at the moment on up here. Okay. Now, pull that out of the way a little bit, put that over here. In fact, I also have on that board, by the way, over here is a, let's get this up right, is a SD card, micro SD. I've got that loaded up as well. And over on the screen here, you can see that it's mounted the card on there, identified that card, etc. In fact, we'll do a directory of that card there, and there's quite a few files on there, a wide directory, and even an enhanced directory over here, which shows us the over here the actual pre-allocated file size that we can go up to without additional clusters if you know anything about FAT32, etc. file systems. But it also prints out a little bit of the header so I can get a bit of an idea what's in that file there as well. Okay, so that's that Tachyon extensions on here. Now, what we're going to do is I have an editor in here called Fred. And on here, I'm going to, it's up in the listing here. If we have a look at it, it's up in here, Fred's up there. I'm going to go and load that up. Fload Fred. And it's loading up from file, but it's also loading in the non-echo mode, simply outputting new names and messages. So it says I redefined org down here, etc. Gives me an end of load report, and it's taking up 16K. That's Fred at present, and it took 1.5 seconds. Now let's run it. Looks terrible, doesn't it? Okay, that's because I've shrunk it down. So I will shrink it down here. I've blown up the screen too much. I've made this fairly wide. Here we go. You can see that now. Okay. All right. What happens on this is it's restored a session from the SD card. It has 1, 2, 3, 8, 9 files that are there. I'll just move along each one. Alt left and right arrow to Fred itself, the source code for Fred. As you notice here, I'll just go back to the start of Fred up here, and you'll see that this is organized as 128 characters bytes wide by 32 lines. This allows it to be sector friendly, and what we can do is a bit like a block editor, except now I'm using the keyboard, my standard keyboard, ANSI controls, whatever I got, VT102 at the moment, doesn't really matter. I allow for both, but I'll make it ANSI, it's more compatible. And I can up and down go through here. I can jump through there. That's fine. Go home, go to the end of a line, for instance, over here, go back up home. And so we can navigate around. We can also select text. Control B, no mouse, but over here, what do we want to do? We want to copy all of that down to there. Up on the clipboard up here, you can see the clipboard over here. A bit hard to point since it's coming off the screen, but the clipboard over here. So is this still coming through okay? Yeah? Okay. All right. So with that clipboard, if I want to, let's make it a slightly smaller bit. Let's do a to-do. Control B, Control C. Down here, let's just pop it in there. There it is. Pop him down there. Okay. So we can do simple little things like that. In this particular case, I'm going to put a block comment around that to comment that out, just in case I forget. If I made one change to Fred, for instance, if I came up here and I said I changed the date for Fred, down the bottom, we can see right down the bottom the title as 220704. What's the date today? It's the 8th or 9th, whatever it is. Okay, so I'm going to put in this, in fact, up here. I'm going to go Control Y, T, and it timestamps that for me. It comes off a real-time clock chip, which you may have noticed. I'll see if I can bring that back up again. You may have noticed in here there's a real-time clock that's been added to it. Okay, just an I2C. I have I2C utilities, and Tachyon is detecting what type of I2C chip it is. In this case, a PCF8563, making the adjustments for it and handling all the time routines for me. And I'll use that up there. So I'm going to make one little change to it. Now I'm going to hit the F10. This is how we can compile the current file, and F10 will compile the lot. Let's see what happens. Well, that looks familiar, and I'll load up there. It used up 0 code bytes. Well, I didn't use, it took away whatever I had before, it forgot it all, loaded in the new stuff, so effectively it's 0. And now I can type ed, and there it is, right down the bottom. You might notice that 2207100013 down in here. I'll see if I can highlight that a little bit for you, right there, down there, okay? So that's all updated. So we can use that with any code. In fact, if I come along here now, what I might do is I might even just lock this into Flash. You like to see that happen? Well, what I'm going to do first is reset everything, clear it all out. Let's see if I can make it a bit larger here at the moment, just so you can see this a bit better. And just by the way, the prompt is just telling us that if we can you see that prompt okay? I'll just see if that comes up there. Yes. It's just telling us that we're in RAM at the moment and nothing on the stack. I have that, and decimal mode. So 2 items on the stack, decimal mode, etc. I always work in decimal anyway, and simply prefix all my numbers. Now, what I can do now is tell it to compile to Flash. I have a shortcut for that. We love shortcuts. And tell it that I'm going to load up Fred. Here we go, loading up Fred. And then compile back to RAM before I tell it to save it. All right, so we're going to save it. And now when I unplug the board, I'm going to unplug it, take the power off it. And there it is, it's all disconnected. Plug it back in again. And looks the same, but now I can type ed, and there's Fred straight away once I drop the size down. I'm keeping the size small for the share screen here. Now, so there's Fred all operating. And as you notice, where were we before? Oh, there's a cursor in the same position in that file. And so this is the thing is that we can have, even the help file is there too. I'm doing up the help file at the moment. As you can see, I have a bit in there about the different controls, but most of them are intuitive. You know, like we want to save a file, don't we? How do we do it in any text editor? Control S. Okay, well, that's what we do here. You want to quit, Control Q. So you'll see a lot of those single control keys there. They make it nice and simple. We go to a page, we go to page 16, for instance, nothing there. Oh, that's a help, that's why. I'm thinking of Fred. I'll go back, Alt, left arrow, go back to Fred, or even Alt. We can jump about too from one page to another, from one file to another, I should say. For instance, over on the tab 9, we have a glossary for Mecrisp. Let's jump to it. Alt 9. That's all we have to do. I like that. I'm going to keep that bit close to where I am. So I'm going to tell it, Control Y, arrow this, put it down next to the help. Thank you. Hold it there. And there's my glossary. Next time I start this up again, that's where it is. It'll maintain the session. And what it's doing too, of course, it's running on SD card. So it's running my file system, which treats a file as virtual memory. But in this case, it's only writing sectors that have changed. So I can save that 1,000 times and it won't make any changes to the SD card because nothing has changed in the file. When we make a change with Fred, by the way, how it works is that I'll just go to a temp file over here. For instance, okay, I'll just grab a spot around here. And if I type in a simple little demo, for instance, which basically says 10 times 0 for do, courage turn line feed, print. By the way, notice straight away you say it should be a dot, double quote, but I also have aliases for these for being able to read them from a distance. You know, I can't always see a dot, but print I can see. Print literal hello world, and then basically what do we do then? Oops, don't forget, and loop. Okay, that's demo. Nothing to it. If I want, I can say just compile that page, try it out. Control F10 will just grab the page or whatever's on the clipboard. So Control F10 is doing something. Okay, typical. I don't know what I'm doing at the moment then, obviously. So so I'll bring it back to where I was over here and bring it back. Where did I go? Temp file. I don't think that temp file liked me at all. Okay, we've seen it compile anyway. I think I know what I did wrong. I didn't put an end of file marker in here. One thing I do in the page editor is say I'm in pages. How does it know when where the end of the file is? Because I pre-allocate. Even if, like in this case, I might have 1 megabyte pre-allocated or whatever, and I might only be using 32K. I just mark the end with, I'll have a look at Fred, Control End, takes us to this dotted line here, and all that is a line of nulls, or zeros. I only need a single zero, but I can see a whole line of them there, and that's the end of line. That's what I did wrong in the other one, and it kept loading back over itself. So what I'm going to do here in Fred is I'm going to go to another page, 110. I've got lots of pages in here, and now I'm going to do that demo again. We're going to get it right this time. Okay, so we're going to print hello world and loop around, and then what we're going to do is put an alt end here, which will put in a marker. Now Control F10 should work. Shoot me. Okay. So obviously I've made some changes to Fred and it's not doing what I want it to do. So it's going to start it back up again and throwing all heaps of rubbish in there, etc. But it doesn't matter. I know it works, so I'll fix that up some other time. And we all know too, by the way, that whenever we demonstrate anything to anybody, that's when it's going to play up. So if you ever want to test your products, present it on mForth 2020. Then all the bugs will come in. Okay? Yeah. So what I'm developing too, I mentioned the tools that I'm developing. I'm developing my own assembler. I'm calling it Flames at the moment for flat macro assembler. I love the flat format because I want to know exactly where something is, because especially in the propeller chip, it was so important that if you had in this location, everything was optimized. And mForth is really good for people who, you know, we're talking about assembly, no assembly language, understand hardware. You understand hardware. You make stuff, and you understand the guts of it. mForth gives you that freedom of being able to interact with it and express yourself in a way you write your own layers, your own language on top of that, on top of mForth. So in here, I'm creating a macro assembler, And what I'll just do is, I've got no idea what's happening up here. Notice too that I can make changes. I can, it automatically saves the changes if I make any changes, by the way. So as soon as I quit, as soon as I jump to another page, another file, it'll save any changes that are there. If, however, I really made a big mistake and the cat jumped up on the keyboard, he does that sometimes too. Control Z, we know this one. Back again. Very good. That's what we want. So it's friendly. It's like a text editor, but it's broken up into pages. We can make those pages longer, but we need more buffer memory for it. And the whole idea is that we can do whatever we want. We have a clipboard and RAM as well. We can move it all around, and it will just do what it needs to do there. And we're working in pages. We can even span pages. I mean, I can come along here and sort of creep up onto the next page, etc. I can creep along that, etc. But the main thing is that it's still a text editor friendly format. ANSI terminal, well, that's a benefit straight away. We only need RxTX. We don't need a lot of resources for this. Even in Mecrisp, which does compile to a very large code, but it's machine optimized, that's only 16K. In my final tachyon, which I'm designing for this processor, when I eventually get to it all properly, it might be 4K or less. So it'll just be a tiny corner. In fact, tachyon, I've built into chips. I don't know if you got me on camera there. I'll put this under the other camera here, and I'll bring that back up again on the screen. Under here, there's a P2 chip. I have my tachyon in the silicon ROM. So it's actually not in a mask ROM, it's actually in the silicon in that chip there as well. So a bit like the old Sun systems, you can boot into it and there's Forth. And that would access the SD card, everything on there. I want to do something similar for the Raspberry Pi Pico. It's a $1 chip. It's a great chip. I want more power. I can have 2 chips. I can have 4 chips. And networking, I have networking software that will network on a 1-wire basis between them, half duplex, like 485, very fast. And so Fred back here is part of this. Fred, for instance, I can come along to Fred and say, well, I love you, Fred. Can you compile my logic analyzer for me and run it? Okay, well, I'll do that for you. F10 on Splat, and there it is. Logic analyzer is running. What I'm going to do is tell it to stimulate all these different pins. I'm going to run different pulse widths and modulations on different pins, stimulate it and resume, and then capture. And there it is. And please capture in real time. And there it is, capturing all that information there. That's one of the tools that I have as well. Macro assembler, Fred the editor, which I'll probably launch a lot of things from, and I'll probably be handling a lot of the file naming and deleting and everything from Fred itself. The Splat Logic Analyzer has a help menu as well. Down there, the short help menu, but Fred has files. We're talking about files before. I love files, not traditional sense, but in that virtual memory sense. So once we quit out of that, guess what's going to happen? I have all these signals on the lines and my SD card on my SD card as well. So I'm going to reset that and just tell it to run Fred again. Oops. Yes. So yes, I certainly messed up all the IR lines. So I'm just going to reset. This happened the other day. What it's done, it's if you know anything about SD cards, you can all those signals on there, put it into a funny mode. What I did on one of my boards is that I built in a little soft switch into the power of the SD card, so you always reset it back to a known state. So in this case here, that was my fault, my bad, and here we go. We're going to start up again, and that should work, I believe. Oh yes, I'm just going to remount it and start it again. And no, it's not doing it. Okay. I thought it was the card. It'll be something there. It'll be right now. There it goes. We're back. All right. We're not fussed about this. We know it's not like Hollywood where you press the wrong button and sparks and flames come out. And it's pretty hard to damage things really. When you have big motors hooked up to it, yes, things do happen. But on the bench, LEDs, we're not going to blow an LED, are we? So there's a few little features there. Maybe, you'd like to ask me some questions. I know Christian had some questions as well. And a few things I can show you now and maybe even later. So any questions?
Thank you very much. Amazing. So, yeah, are there any questions to Peter? So there's one question in the chat. Demitri, go ahead. What's this, Demitri? Whoever wanted to ask a question, please go ahead. There was one question in the chat with regard to where to get the source code of this, and I think that it's somewhere on GitHub and in a Dropbox that you share.
Well, Ulrich, that was the idea of having everything what we present on the mForth 2020 GitHub, because people don't need to ask. They go to the mForth 2020 GitHub and they will find Peter Jakacki folder.
Yeah, right.
And from there he can link to his repository.
Okay, I've got it up here. Hopefully it's on the screen there, mForth 2020. So there's GitHub, that's a slightly older version in there, I think, but I'm going to update it after this with the latest. So it has in there the Tachyon extensions, README instructions. It has a couple of little scripts if you're on Linux for the communications. And the mForth folder itself, in there I have Fred, Splat, the logic analyzer, I have Tachyon, and there's even a display driver as well. There's lots of other files in my Dropbox, and that's where I normally work, and I've just got updated on here. And once you have those files, I also have an SD card folder as well that I will load up on here, and they give you the exact images that I use. So for instance, at Fred, you can just put it on an SD card, copy it on there, put it all in there. And once you have Tachyon loaded, you can do what I did and just do an F-load, Fred, and even flash it, take it from there.
Very good. Yeah, thanks for contributing this and making this available. So I think from reading what is in the chat and my own estimate is that it's really an amazing project. And yeah, really, really nice. And a failed demo shows how much effort is in there and how well it normally works. So great. Are there any additional questions? No?
My questions were answered by Peter.
Okay.
Ulrich, I do have some question.
Yeah, Christian, go ahead, please.
I can't find my list of questions that I added to Peter's publication, but I remember one that was bugging me. It was, how do you add data coming from the PC into Fred? Let's say you've got Fred running and you'd like to add data to it, but it's coming from the PC. Okay,
there's your questions up there. Would you like to clarify this, how Mecrisp was transformed into Tachyon? And here, I'll just answer that first, Christian. It's transformed in that the whole user interface is like Mecrisp was like you type something, it wipes the stack, and error would go off and keep repeating. And so at the moment, it's made it friendly and usable for development. And also, I've integrated the hardware much better into it. I've actually got the PIO language I've got to integrate into it. There's a whole heap of things, and as you saw, the FAT32 as well, and just everything just to make development easier. Now, the other thing you asked was, what are the words that attack you on those that are Mecrisp original? Well, Mecrisp is still there. I have the glossary there for it. And, I'll get around to like Bob Edwards, who's also on Forth 2020, documented tachyon as it was on the propeller and tacos. And I'm sure he will help out in documenting tachyon, but in the final form. This is the intermediate form of tachyon. And you also said that all the Mecrisp words are still usable, and also too that the commands for the editor thread, well, they're in the help file itself. So once you load it up on the SD card, you can just open up that file. But most of them, except for the unusual commands, most of them are just natural. You expect them to work that way: delete, backspace, copy, etc. And the other thing too is, what's the latest evolution with Mecrisp tachyon? This is where I'm at. I've been so sidetracked playing with Forth. It's a very productive and non-productive language. You get a lot of this done, but not a lot of that done. This is what happens. And we can just go back to Mecrisp. You saw that before. I save a copy in the flash. The flash is large enough. You just use the load hash, load pound symbol one. I normally keep a copy of it in one. I'll just show you a copy of that now. One, load, and there's Mecrisp, raw Mecrisp. And I have different copies in there. Now also too, very quickly, Christian, just finish off so I don't take up too much time here, is the equivalent of include. That's include. It's right in there at the moment. When we look at that, we'll see that. I'll load everything back up again. Reset. Okay, I've cleaned it out, but back again, and up in here, what we're going to do is just find include. And I'm going to case sensitive at the moment, so include is right there. Notice this directive I have up there, if you can see that well enough, and it's showing that we have an include directive that includes import, and we can import another file, and that file can import another file, etc. We can stack that as well, and I made it look just like the normal include directive, so it works just the same. I don't need to do it, but I've just made sure that I can do it. And the other thing that you're asking there before, Christian, is I know it was down in here, the questions that you had. I'll put it after the end of file. I can cheat. You can add extra text to it after the end of file marker. So you also asked how to import PC code into thread editor. If it's small, I can paste it in from the terminal. Not the best way. Normally, all I do is I take the card out, put the file on here on the card itself. It's a normal text file, and then I'll just show you what I do. I'll do a quick demo. I'll put that back in again, and of course I'll put the card out, so I should remount that. And what happens is F12 shows me directory. I have in there a file called character lcd.fth. What I'm going to do is open it up. So eventually, this is an old file. Notice that format there. It's all over the place because that's just a normal text file, and it doesn't present well on here. I'm going to do an Alt S, save as character lcd.f. Just so I can distinguish between the normal text file, and it will create a page file format for me and format that all for me. Now I can just use it. But nothing works. It's in view mode only, as you might notice up the top here. Bring it back down there. View mode only up the top. I go Control E, and you see that edit mode up there. And then once that happens, I can type in there, in this case, Control Z to undo it. So that's how I can do that. Any other questions?
No, I think it's fine. Thanks for answering my questions.
Right.
Utley raised his hand.
Oh, yes.
Please unmute.
Yes. Yeah. See your lips moving out there, but
I might have one more.
okay.
The prompt that we get in Tachyon is a letter, a number, the crosshatch, and the colon, I think. And most IDEs that work with Forth look for OK. Is there a way I could add an OK in there?
Sorry, do you just mean the OK that we get when we're OK? Yes, but what happens, I think, is the OK is a bit of a primitive interface. One thing I always want to do is if I copy and paste code on a forum, anywhere else, and so on, the person unfamiliar with Forth doesn't know the difference between what's been typed and the response. Here I go 1, 2, 3, 4 plus print, and you might see it up on here, and you'll see that it prints out 46. Okay, it's got a comment separator there. I use 3 dashes, so it's explicit. It's not confused with an operator symbol and so on. And it says this is 46. So yeah, you know, the whole prompt, the whole thing is totally, you can change it all the time, because this is exactly what happens when I do a block load. All that stuff disappears and it's not giving me that anymore. It's just spitting out, once I do Mecrisp, for instance, because it's based on Mecrisp. So that's my keyword. And now 1, 2, 3, 4 plus, you can't see anything coming through, but you do see an output. Okay, and it's looking for another keyword, end, and that's done. So yes, you can change it on the fly as you go. And also, as you can see, I use colors. I want to see what I typed, what's come back. When I type words, for instance, there's the words there coming up there. Let's make sure it's come up. Yep. So color coded for variables and constants and so on, and immediate words. And also have shortcuts. So shortcuts can basically, all those control keys are normally useless on a Forth console. I use them. I can assign functions to them. And in this case here, debug Control D. Well, even if the console is stuck and it can't scan the dictionary for my word, etc., I do Control D or Control W, and it will produce a result, and also clear the stack for me, do all these different things. So yes, there's a whole heap of features I keep forgetting about that are built into it already.
I'll add one thing. With the standard Tachyon prompt, is there any part of that prompt that is fixed and could be used to recognize the fact that the Tachyon responded?
Sure. The thing is that what we're doing at the moment is there's the prompt there. That suits me. This is development. This gives me straight away, it tells me there's nothing on the stack. It's in RAM mode, just mode. Everything's normal, and I can see input and output. As I said, look, in the Tachyon code itself. Let's see if we got it up here. We'll go back to Fred, etc. And we will. Yes, well, we've gone back to the schedule here, by the way. Looks like Forth is changing back, but it's okay. What's happened is, we'll leave it like that, Peter, that's fine. But basically what happens is that in Tachyon, you will notice I'll have different hooks. So I just reassign them as I need to. And I'm sure I can give you some instructions on that, but it's very simple, really. It's
you
so
probably
simple.
already know why I'm asking all this, because I like using the Zeptoforth JavaScript terminal, and I can't make it work properly with
the
the
yeah, but this is a totally different thing altogether. As you can see, when I load Tachyon, even when I load the whole Tachyon source code, 3,000 lines of it, how long did it take? Less than 2 seconds. Why would I want to go backwards and forwards? All I want to see is that it's got it all okay. And if there are any errors, well, it'll show me which word it was, and I'll go back, look at the source. I just wouldn't do it the slow way. It's that I did that back in the 80s. I would never want to go back there. 9600 baud, slow. And that's what people hate about Forth, I think. You know, I remember Forth from the 80s, slow, you know, to load code. But I load, as I said, 3,000 lines of code like that from serial terminal, and also at the same time loading from file. But you can do what you want with that's Forth.
Marvelous, fantastic, excellent, fantastic questions from Christian.
Very good.
Christian is the champion of the questions, and he makes very interesting input for the group.
Sure.
And this allows Peter to explain better his project. He's fantastic. Okay, guys, I have in the schedule Klaus Schleisiek. Klaus, are you in the meeting? I can't see you. If Klaus is not in the meeting, the next participant is our dear Ulrich Hoffmann from Hamburg, and he will present something that all people in this community are asking. Please, Ulrich, explain us tutorial data structures, because we want to know more about this. And this is Let's Go for Objects.
Okay, right. Yep, let me see. I will share my desktop and right, so where's the presentation? Here we go. I had some previous talks about data structures, and we looked at how to realize records, structures or arrays in Forth, either in RAM-ROM systems or in virtual memory, and things like this. And so this is the ongoing schedule. Before the last time we looked at Forth arrays and how to do with this, and I promised to come back to structures and records, so that we can also have a look at how objects might be realized in Forth. And if you remember the structures, we had fields in there and we stored data in them, and we did the address calculation either by hand or by using a defining word. And well, let's talk today about how we can extend this very easily to also deal with object-like structures. So, and for this, I will first talk a little bit about data and code. And if we think about how code is referenced in, or can be referenced in Forth, then we will come up with execution tokens, or the code field address, or maybe the name field address, or whatever, something that allows you to refer to a word so that you can put it on the stack, put it in variables, and finally execute that word. So within standard terms, this is the execution token. And we will talk a little bit about variables and also the defining word deferred words, execution vectors that can hold a reference to a word. And when they are executed, they essentially execute their reference. And so that's something that you can read up in the beginner's books as well. And well, of course, we want to see how can we bring this together with the structs, the records that we saw earlier. Can we have execution token in structures? Yes, of course. And then we will have not only data within our structure, but we will also have behavior words, or you can call them methods if you want to, inside a structure. And thus it can behave like an object in other languages. And again, as we normally do in Forth, you will build these things on your own. So if you get a Forth system right out of the box, it normally doesn't have all these structures. So you can go ahead, if you know what you're doing, go ahead and build the appropriate object-oriented structures, data and code together in your Forth system, depending on the application needs that you have. If you do not have just a single behavior that you want to attach, then of course you can just add up fields with more execution tokens in your structure, or something comes up that is the so-called virtual method table, and we will have a look at that as well. So let's talk about data and code in Forth. You have to plan all the memory layout and all the techniques to implement this on your own. Hopefully there are people that can tell you about it, and you can read it up in good textbooks. You can also pull something from a well-used established library, or you use a Forth system that provides all this already. So in Forth, we store normally things in cells. Either it fits in a cell like a character or signed, unsigned integers, or it doesn't fit in a cell, then we use several cells to store the data that we want to. So part of the data is stored in a cell, and we arrange all this on our own. And during the course of the talks I gave, we looked at arrays and structs and how we do this. So it could be measurement data, or it could be dates, or it could be temperatures, or whatever. It could be statistical data, sound information, or whatever the data is that you're dealing with. So that's not unusual. You do this in every programming environment. In Forth, we can also store execution tokens and refer to words, as I said. Different Forth systems use different ways to reference this. So in the early days of Forth interest group Forth, it was the parameter field address or the code field address that you would use for referring to a word. Today, it's all abstracted away in the standard discussion, calling it an execution token. So it's some number that is just a good identifier for a word, and you can tick a word to get that identifier, and you can execute the identifier to actually invoke a word and execute it. We all know about that. And so because of this, you can store these execution tokens in variables, and that's what we will do here as well. I have a small example. A variable greeting that holds the execution vector of the word that will do the actual greeting in our system. And we have two different behaviors that this might have. So it could be night, or it could be day. And so whenever I want to have some greeting, it will be executing night, or it will be executing day, depending on this. And then I have two words, dawn and dusk, that store the appropriate execution token in the variable greeting, depending on whether it's dawn or dusk. And then I have a word that actually extracts the execution token from the variable and executes the appropriate function, the appropriate word that is in there. So with this setup, I can say dawn greet, and I get hello, because in the morning I'm happy and I want to greet everyone with hello. And if it's dusk, sundown, then I say dusk greet, and then I get good night. So dawn and dusk switch the execution vector that is actually stored in greeting to either day or night, which will eventually, when executed, print out the appropriate things. So that's very basic Forth. You only need a tick to get the execution token of a word, and you need execute to execute this. All other things are done with fetch and store, like we deal with normal variables all the time. Then maybe you don't want to do this because, well, you have to execute this value explicitly, and you don't want to have this. You want to hide it in somewhere, in some way. And this is typically done with a defining word on its own. So you have variable-like things where you can store execution tokens, but that actually when you just name the word, it will go ahead, fetch the execution token and execute it immediately. And this is what the word defer normally does. You do things very similar. Instead of variable, now you do defer greeting. You use the same words as before. And then because if you just say greeting now, it will try to execute what its content is. You have to somehow have special fetch and store operators. That's what you get. So here's a defer store that you can use for storing a execution token in a deferred word. Or some FORTH systems use the is syntax to do it. So you say tick bracket tick day or tick day as before, is greeting, or the way I did it here, bracket tick day, bracket tick greeting, defer store. So this is more complicated, but using the deferred word and executing what's in it is more easily done. You just name the word. And of course, you see here, greet is just greeting now, and we could just call the deferred word greet, and then we could just get rid of one word. The usage is essentially the same as it was before. So we can have this defining word, and it's very easy to define it. So instead of just putting the address of the variable on the stack, it will just go ahead and fetch and execute what is in there. And defer store will go to the appropriate parameter field and store the value in there. So that's what it is. Right. So that's that. And now let's see how can we combine this with the records that we saw earlier, or the structures that we saw earlier. This is a review of an old slide that we saw in one of the previous talks. It defines a structure using the plus field record that defines words that actually do address arithmetic, starting from a base address, add an appropriate offset so that you can go from the beginning of the structure to the appropriate cell where the field is stored. So X actually does nothing. It leaves the address unchanged, but Y underscore Y actually in a 32-bit system does a 4+, so that after executing underscore Y, it calculates from the base address to the beginning address of the appropriate Y field. And all this does the calculation. So later on, you know, when you are at the end of the definition, how large the new structure is, and you can just create it so that you can later on use it for allocating appropriate space. So this is also, in the meantime, it's the standard way to define structures and to do this. And then you can store different things without further being aware of the memory's layout. You can store a 3 in the X field of the record, and you can store a 4 in the P field of the in the Y field of the record, and then you can do some calculations on it. And so that's what we already saw. But now we want to add behavior to the FORTH structure, and we do this. For example, now we have a point, and we want to plot the point on screen or on a display, as Peter showed us the last time. We want to plot the point somewhere. And now we add another field, and this field actually contains the execution token of the function of the word that will actually go ahead and does it. This execution token will have a stack effect. It will take the structure address from the stack, and it will just carry out what is necessary. Maybe in other behaviors, we will have additional parameters, but it's very typical that we get the reference of the structure so that we can access the appropriate fields in it. And a typical way to do it is we get the x coordinate from the point, we get the y coordinate from the point, and then we invoke some graphic primitive that is able to plot on screen in a canvas or whatever we want to do. And that's the execution token of that word is actually what we want to store inside that field. So later on, we can go ahead and execute it. And because the execute is normally explicit, like in the variable case, yeah, we need to fetch and store the fields in the setup that we have. It's better to have another word that will do the fetch execute on its own. So we define the word plot, which actually extracts the execution token from the first field and execute it in a way so that the point address is still on the stack. So that satisfies the stack effect that we have here. And so then we have a structure that has one field more. I added this at the beginning. So we have the execution token of the plot it parent plot it word in there. We have the x coordinate and the y coordinate in there in the next field. So 3 fields actually. And if we do plot on it, it will extract the execution token from the first field and invoke it, and the function plotted itself will extract x and y and essentially call the appropriate drawing primitive. So after we did all this, we store the coordinates. We can just say pplot, and then it does the magic that I just described. It will go ahead and plot the appropriate point there. Whoa. Right, so that's something that that we can easily do. It's only fetch and stores and execute, so nothing more fancy than this, but used in a clever way to actually do this. And well, maybe not so nice is that we need to define a colon definition for every execution vector, and similar to variable and defer, maybe we want to have a defining word that is not just giving us the address, but also does the execute on its own. And this is the next thing that we do. We say, okay, maybe we have some defer-like fields in our structures. And so we use a new defining word, which we just see in a moment how it looks like, plus defer, similar to plus field, that defines a field that executes its execution token whenever we put some data in it, or whenever we invoke that word. And because we also want to store values in it, it's good to have to keep the name underscore plotted to access it in a variable-like way, and plot it to execute it. And we can easily do this by influencing the address calculation. So if we do 0 cells, then it wouldn't change the address calculation, and only it only gets incremented with the 1. So essentially, it's an alias for the same field, but plotted without the underscore in front will execute what is in there, and underscore plotted will return its appropriate address. Ooh. And similar, so the main effect is that we don't need the fetch execute anymore, because it will be the execution part of the deferred word. So let's see how this looks like. Plus defer looks like it's actually a field, but instead of leaving just the address there, it goes ahead and fetches the value and executes the appropriate thing. So I'm not quite sure. Yeah, it works. maybe it needs to do address calculation. I'm not sure, but you get the idea. So let me see how this works. Okay. Right, and then we allocate the point as before, and we can use it as before. We store the appropriate execution token in there, and then we can just go and use it the same way as before. So the idea, variable and defer, and field and plus defer, that's the idea of doing these things in this way. So we can add behavior to our forth structures, which means yeah, we have additional fields with execution tokens in there that operate on the data that is there. So we have behavior and we have data, code and data side by side in our structures, which is essentially objects. And so let's see. What if I don't have a single behavior, but I will add more behavior, like move the point to some other location, for example. And I don't want to do this or copy a point or draw a line between a point and the origin or whatever additional behavior I might want to have, not a single one. What I can do is similar to this. I add another field beside plot it and x and y, and then just augment my record with the appropriate execution tokens. But what I also can do, and this is sometimes reasonable, if many common structures share the same behavior and only are different in the data part, instead of adding more execution tokens in the record itself, add a table of execution tokens and just refer this with with the address that is stored there. And that's a technique that is called the virtual method table, the way that C++ does object-oriented programming. So the objects in C++ will just have virtual method table references in the first location of the structures of the object that you use. And so instead of executing the value directly from the field, you have to follow the indirection, and you have to index into the virtual method table to get the appropriate things. But this way, the address of the virtual method table can be shared with all objects that are alike and share the same behavior and are only different in the x and y in the data that you have. So if you will build this, then it changes. So you don't have the execution token here, but a reference to the virtual method table. And you build up a virtual method table where you store the execution tokens appropriately and you initialize the object appropriately. And then you can just go ahead and do the same thing. So the virtual method table actually adds an indirection and some indexing to the calculation of the appropriate execution token, and to make it more versatile, more reusable. But for simpler cases, it's very reasonable to just store the execution token in a record and then execute it in the way that I presented. Right. And so if you are interested in this kind of things, then it's probably a good idea to have a look at minioof, minioof2 or bandoof, the three systems that Bernd Peisan presented many years ago over the time. Minioof is a object-oriented forth extension in a single screen. OOF2 is a little bit different, this a little bit more elaborated, and bandoof actually introduces the notion of an object stack. So because you see here, it's very difficult. You have this reference to the current object, to the current structure, and you have to have it on the stack, and you always need to deal with it. And you have the data that you extract, but you need to somehow keep the reference. And this could be cumbersome. And if the reference is actually on an object stack, then the code that resides in there will become much more easy to manage, but it will depart a little bit from standard forth in that way. You have to define that object stake and manage it appropriately. Right. So let me conclude. Yeah, we looked at data and code. Forth is able to store and manage both by the means of execution token. You can refer to words and their behavior. You can store it in variable and deal with it. Many systems do this with the IO system, for example. So they have variables that hold the word that actually does the printing of a character or reading of the keyboard. And if you want to divert it to some other place, you just store different values in these variables, or you can use defer to actually do it in the same in the same spirit, but in a different way, by having the execute implicit in the defining word. And you can do the same trick with structures. You can store execution tokens directly there, or you could do auto fetch and execute fields that actually go ahead and execute the word that is stored in the field. And then if you want to share behavior between objects, then you would go for a virtual method table. Wow. So this, to conclude everything, sums up and completes the data structure part. So we looked at earlier, we looked at structs, we looked at different flavors of arrays. Now we have object. We also looked at enumeration types. And yeah, so that's actually what's I think is in there. And in typical applications that are more complicated than just start applications, in one way or the other, you will need to define structs or arrays or maybe enumeration types, but probably also objects if it becomes more difficult. And so it's probably a good idea to know how these things work. And yeah, so this brings me to the end of my talk, and I'm sure there are questions. I will bring up all the slides of the talks that I did previously, and this one also on the GitHub for 2020 repository, so that you can refer back. And of course, this is recorded. You can go back and watch the recording. And yeah, but I'm still open for questions, of course. So that's it. Atle, thanks for the thumbs up. So please do not hesitate, open the mic and
wonderful, Ulrich. Fantastic.
That's great, Ulrich. Can you put some links on for the mini oof and burn and all that?
Actually, I think it's very easy to Google it, but I will do it, and the link that I get, I will just put in the chat.
Yeah, I just tried to Google it. It's not.
Oh, okay, right. Yeah.
Yeah.
Okay, maybe I'm more successful than you are. I will do.
Ulrich, let me ask. I'm Matteo. Hi. I think that the first version of the point has a redundancy because you repeat the execute address in every object you define later. While when you use the virtual table, you are acting very object-oriented. Like I think there is. I got it this way, I think.
Yeah, you can actually do both. It really depends on whether you have very similar objects that are in the same behavior and are only different in the data that you work on. And in typical object-oriented systems where you have classes, then the class actually captures the behavior of all the objects that belong to that class, and they only are different in the values that they hold. And then you would go for this virtual method table implementation.
I don't say that is wrong or right. Both are good in what you are doing, you are wanting to do. Yeah, exactly. This is
exactly.
Forth.
Yeah,
Exactly.
yeah, and the first option is often if you have something that is some systems are called said to be object based. So the object stores all the information that is necessary to hold it. There is no class at all. And then something like storing the execution tokens over and over again, even if it's the same behavior in the objects, then that's then the way to go. And I think, yeah, we have the choice. In Forth, we have the choice. If you are a C++ programmer, then your object-oriented programming is virtual method table and or early binding and resolving everything. But your object implementation is virtual method table, and you have no choice. In Forth, you have the choice. You can also just store things in fields, and it comes up with this, in the end, it comes up with the same syntax that you can use. It just
anyways, as always, Ulrich, you bring in this discussion very good ideas. Thank you.
Thank you very much. Yeah. Right. Are there other questions?
Christian again. I think I'm going to slip one.
Yeah.
Ulrich, in ESP32 APIs that are built as a big binary blob inside the ESP32, they frequently require a structure as a kind of pointer to all the data that will be used by the API. I'm always having a hard time to create this structure. Could it be created in Forth and then pointed to as one pointer in the API? Because the API requests a pointer to the structure.
Yeah. So the structure typically is defined in C, I guess, if it's ESP32 Forth and if it's in the blob. So you have to see how is the memory layout that the C compiler will do for the structure. Yeah, and if you understand it and you know how the memory layout is, then you can use this technique of creating Forth structures with the appropriate fields. And essentially, it will mainly be whether you have one cell or two cells or whatever, or just a single character in the fields. And if you match, you can do it in this style. If you match the structure of your record with what the C compiler expects, then you can just pass in P, which is the address of the beginning of the memory region, and that will work.
So more or less, I either do it in C,
yes,
the proper structure for what I want to do, or I could do it in Forth and just pass the pointer to that structure.
Yeah. The challenge really is to define the Forth structure in a way that it has exactly the same memory layout that the C structure assumes.
Yeah, the API describes the structure in detail.
Yeah,
I will add something for Christian understanding. We have structures in ESP32 Forth, Christian, and we also have the OAuth of Bernd Python implemented by SuperBob on the ESP32 Forth site. If you enter the ESP32 Forth site of the group, you will find structures are there, and they are not compatible to the GNU C compiler. This is different. This is different. You cannot do that. But in C, when you pass one function, the structure to another one, many times you are passing this also over the stack, the same as it happens in Forth. But you need to work with the stack. You need to think in Forth, and you need to see. You cannot copy something from C into Forth. You need to think in Forth and on the Forth stack.
Yeah, but that means I might have a hard time using the APIs that are built in the ESP32.
No, Ulrich explained to you. You can pass a pointer also. You can pass a structure or data structure by a pointer.
Yeah. So, and if it's easy or difficult depends also on the complexity of the structure. So if it's just like this with two fields, and then it's quite easy to repeat this in forth and then pass it in. But C structures could also be very complicated with alignment.
It can be a structure inside another
and,
structure.
And lots of things. So it really depends on the special case, I guess.
It sounds like it'll be better to do the structure in C and just use it.
So that's
okay, thank you.
Could be less error prone. Yeah.
Also keep in mind that depending on environment and your compiler settings, your structure layout in C will change. You can optimize for speed, you can optimize for size, and compilers have gotten really good at mixing things up. When you do that, that means if you have a mix of environments, Forth and C, depending how you parameterize your compile, your Forth part might access regions that used to be there, but courtesy of the compiler being told to do something different, are not right now. We need to be really careful with that. Right. It's doable, but it's messy. It can be messy. If you don't maintain it properly, it will be messy.
Yeah, the solution is if you want to communicate with other languages, you are bound to use things like int 32, float 64, and otherwise it doesn't work, especially if you change the options for the C compiler.
Thanks for all those warnings.
Yeah, that's always a difficult thing, because you have two things that might easily diverge, and yeah. Right, so thank you very much for listening, and I think our next speaker then is Bill Ragsdale. And you probably all are very keen of the Wordle game and do it frequently. And so I'm very happy to learn about a toolkit for Wordle, and Bill will talk about that. So please go ahead, Bill. So
well, good morning, gentlemen. Yeah. Good afternoon, good evening, whatever time zone you're located in. Discussion today is on the word game Wordle. This is developed by a programmer about 1 year ago. He worked on it for several months and then sold it to the New York Times for a low seven figures, somewhere around $2 to $3 million. It's available in most languages with variations. There's been a lot of copies on it. So look up Wordle or its derivatives, and you can find it in your own native language. Our family's been hooked on this. Every morning we get up, and for the first 15 minutes, I solve it, my wife solves it. She goes to her sister, we talk to our daughter. We all figured out who got the word and how much work. So I've worked on some toolkits that are just fun from a Forth standpoint to try to optimize my understanding. So the basis of the game, first is, there is an unknown 5-letter word. We will explore how to identify in a efficient way what that unknown word would be. So first we guess a 5-letter word. You get 6 tries to try to match what the unknown word is. You will see a green highlight on a letter if it's in the correct position in the unknown word, and it will be shown in gold if the letter is used, but it's in a different position. So that's the basis of the game, and you have 6 tries. Here's an example. This is real life. I just guessed the word ridge to begin with. I'm not sure why, but I just guessed ridge. And sure enough, I have a gold I, D, and a green E, so that's a good hint. Those three letters are present. So then I picked the word doggy. Incidentally, the word doggy is either a small dog or in the Western United States, it's a young cow, it's a calf. It's a dogie. A dogie is a young calf. And in that case, I now have a D, O, I, and E determined. Then I guess diode from a technology standpoint. And that gave me some more clues about where the letters are not used. And then finally, I picked oxide, which was the winner. So here's one Wordle toolkit element. First, we're going to develop the list of 5-letter words. And actually, I am using the live Wordle set. We'll talk about it in just a moment. So it's a list of about 2,900 words. We form an evaluation criteria. So how close can one word be to another following the Wordle's gold and green clues? And then finally, for each of the words, we'll rank its closest to all the remaining words, and then we'll rank them. So here's the word set from Wordle. Every time you load Wordle into your computer, the entire word set goes into your browser cache. There's 2 word lists. 2,700 words are the words that will actually be used as your unknowns. And then there's another list of about 9,000 words that are possible English words. They will be legitimate, but they will never be used for the Wordle game itself. They're mostly obscure words, and they only want to try to focus on words that are commonly in use. So the highlighted letters here are part of the 2,900 normal target words. This is an example of how the ranking criteria works out. In this case, I'm going to have n-letter words, n-letter and 5-letter words, and you'll see in a moment it's about 2,900. And then we're going to scan through each word in the remaining words in the list and compare the letters. If the letters are the same letter in the same position, we'll score 3 for that letter. If the letter is somewhere in the word, but the position doesn't match, we'll score 1. So below is an example. We are testing the word stare, and in this case, we're testing against the word toast. And we see that T scores 1 in the red column on the left because T is in use in both words, but not in the same position. O scores 0 because it is not used. The A in the center position scores 3 because you have the same letter in the same position. The S is also scored as a 1, and the final T is not scored because that letter has already been scored beforehand in the very first position. If T had been used twice, then it would have gotten a score of 1 twice. So that's our scoring position. These totals are accumulated for each particular word, and then we go on to all the words in the sets. So we're making n to n-1 comparisons. This is a simple Win32 setup on reading the word file. We name the file, we open it to get its file ID, we then read its file size, and then we copy the disk words into a fourth array. It's just a linear string of letters. We need to count the number of words that we're processing, and the key factor here is in the second line, which says do I cfetch ASCII comma equals. We scan across each, we scan across all of the letters in this large array. We count the commas because in between each Wordle word, there's a comma. We count the commas, and at the very end, it says loop 1+. There are always one more word than there are commas. So this gives us the total number of words in our target file. Now I'm going to use my matrix utility. which is the word create left bracket. So we count the words. We have it's a 2,900 by 2 matrix. We create the matrix called word set. And that will be loaded then in a very structured form with all of the Wordle words. This word is fairly involved. It loads the matrix. It is just scanning across the text input, the linear file, or the linear character string, and converting it into the matrix structure. Again, 2,900 rows by 2 columns. The first field or first column is the 5 ASCII letters of the word, and the second column is the summation of its score. There's a utility, so we can look at the word matrix. This just prints the word set. The first highlighted line is a dupe I0 double bracket. This gets the word from the column 0 and prints it. The next line prints the closest value. Whenever I write a matrix word, if it's non-standard, I immediately have to write a word to reveal it. And often I will write the word to reveal it before I've written the word, because you need this immediately for testing. This is our starting setup. We take our word set, and with the bracket form matrix, the input text and the linear text string is converted to matrix form. And then we take word set 10 print matrix. We'll print the first 10 entries. So from the Wordle set, we see the leading words are cigar, rebut, sissy, hump, awake, blush, focal, and so on. And they currently have no score. If we go back to that highlighted text file you saw a couple of frames ago, these are actually the words directly out of the browser cache. So here's the scoring of one word. The first section looks for the 3-point scores. The second section looks for the 1-point scores. It's essential that we score the exact matches first, and then the letters that are unused by the exact match are done for a 1-point match. So the first do loop scans across the 2 words looking for a match in the same position. The second do loop scans across the words looking for any match. The former word just score, the former fourth word just scores 1 Wordle word. This now scores all of them. So this is a very busy process because we're doing n to the n-1 comparisons. One of the key factors is 4 lines down, you see a 0 do ji greater than less than. This is avoiding the word being compared against itself. So for all words, not the word itself, the following conditional is done. We look at the new guess, we look at the unknown, we do the scoring. In this case, the word negate is in there because this allows me to either do a sort looking for the most commonly used or the least commonly used. By putting negate in there, I can reverse the effect of an ultimate sort. So again, the previous fourth word scores the either 1 to 3 points for each word. This extends it through the entire matrix. So we see our high ranked words. Well, my favorite word is stare, S-T-A-R-E. It has the highest rank scored. These are negative because I did that to force it to sort smaller to larger. Stare is useful because A and E are the most commonly used vowels, and S, T, and R are the most commonly used consonants in English. And we see there are other rearrangements of that: arose, raise, arise, slate, erase, and so on. They're all very similar. And you would, in fourth, you would get the same advantage by using any of these very common words, or the words that have a very high relationship to other words. On the other hand, look at the low ranked words. Fuzzy is the least a common word because it's using the lower use vowels U and Z and F's and ZZ. Fluff is interesting because 2 days ago, that was the actual Wordle word for the day. So fluff, the second least commonality word, was actually used by the official Wordle campaign a couple of days ago. And it does present some real problems on trying to figure it out. We see other words like jumbo, jiffy, jazzy, mummy, whiff, and so on, of the least used words. So by this process, we have given us the clue words and the most likely to be used, the least likely. My next process, it will be to work a process for picking the words in sequence. And I believe what the best is going to be is to, number one, pick a high ranked word. And then number two, pick a lower ranked word that uses none of the above letters. But we'll get into that possibly in a future word. Here's our result. As we see, there were 2,309 words in the preferred list. In our evaluation, we have to make 5.3 million word comparisons. This is n to n minus 1, and that involves 133 million letter comparisons. In Win32Forth, that took 24 seconds. Then we do a bubble sort on the words to put them in order. And again, it's a 2,300 item bubble sort, which involves 2.7 million floating point comparisons. To my amazement, this takes 6 seconds. Really quite brisk comparison considering the work that's done. And as an equivalent, it's about 0.45 megaflops. Some people say Forth is slower than other languages. In this situation, it's certainly fast enough for me. And do we have any questions? Keep them simple and keep them focused, please. Very good. That's the way you like it. I like a clear presentation, minimum questions, and stay tuned. In a month or two, we may have another Wordle episode. And by all means, try the game. It is intellectually very, very infectious, very infectious. Thank you. And back to Ulrich.
Thank you,
gentlemen.
Thank you very much.
Yes. Yeah, we also started to build it on our own without any computer, with just index cards and thinking out. So one is thinking out a word, backing up a word, and then we do the score with paper and pencil. So that's also very communicative. So it's a very nice game. So I can, if you don't know it, I can just recommend playing it. Very entertaining. Right. Are there questions to Bill? Other questions? So then, thank you very much. And so let's see. Then I think in today's discussion, we already heard about Zeptoforth for a little bit, and so I really are curious, what is this all about? So Travis Bemann will probably explain it to us, and let me see. Travis, are you ready to talk about Zeptoforth and show us what it is?
Yes, I am ready.
Okay, great. Then I would just say the stage is yours, and go ahead.
Okay. Okay.
Yeah, we can see your screen.
Okay. Here we have Zeptocon.js. I'll say just Zeptocon for short, running a little program on the STM32.411, which is reading the CPU temperature field. Note that I'm not doing any conversion of it, so it's just the raw value. And the console's on user 2, but I'm spinning out the values over user 1, which we can see here. Yeah, that's just what I had running previously. And I'll first go into Zeptocom. Zeptocom is a fourth web terminal, and it's designed originally for Zeptoforth, but has support for a few different target types. More can be added in the future. And it's got two main panes here. One is the terminal, and one is an edit box. And the edit box has tabs. Just as of last night, I added the ability to display the file names in the tabs. So here is a simple test of the number of words that use quotations or lambdas, you might say, within Zeptoforth. And I'll kill what I had currently running on there, and I can send the code over, which I've got something called strip code selected, so that when I hit send, it sends all the code without any of the comments or the initial white space or whatever. Well, it doesn't strip all comments, but it strips the comments that it can reasonably predict are not going to be within other string literals. And it's got a REPL line where it runs all the tests, a history where you can see what has been run previously, which you can go and use arrow keys to navigate. It has something called includes, which I'm not going to show it right now because I normally use them for when I do builds. Or see includes here. And if I upload this, which I'm not going to do right now because I've already got code installed, it'll expand each of these into the containing files. But I can, just as a demonstration, I can expand it right here. And here it will go and allow me to select a base directory for the includes, which is necessary because otherwise the includes are relative to it, so it doesn't know where to find the file is otherwise. And I confirm, and it expanded all my includes into the containing file. And as you can see, whenever you make an edit to a tab, it puts the tab's title into red until you either save it and then it goes and undoes the red and it sets the name of the tab. So, and of course, there's some features like you can set the baud, the data bits, stop bits, parity, flow control, as I showed, target type, and also the new line mode. Note that the new line mode normally is defaulted based upon the target type because different targets default to different kinds of new lines. Like for instance, if I selected Mecrisp, I would go to there. But I guess that's not going to do anything useful, so I'm going to switch it back. And I also have a timeout feature. For instance, if I go and make a word that, let's say, goes, takes but I wanted to interrupt at, let's say, so I don't have to wait that long. Unless it's 3 seconds. I'm gonna send. And it times out. This is useful because while on some platform, for Zeptoforth, it uses something called ACK and NAC for flow control. Whereas where it uses ACK to go into the ACK byte sent by the target to say send data. And it uses the NAC byte to say, hey, an error occurred, stop now. But on some of the other targets, there is no such feature, there's no NAC. So the user could specify a timeout instead. And if no okay is received, because in Mecrisp, STM8, and ESP32 modes, it relies upon an okay type message being received. If it's not received in time, it'll time out and it'll display this message interrupting the output. But let's say I turn that off. I'm going to send that again. I can manually interrupt it with that. Okay. Now that I've explained, and and I'll show disconnecting and reconnecting. You can set, while it's disconnected, you can set all these fields. Normally, the defaults are provided are good defaults, but you can do things like, for instance, I'm going to change my console's baud rates. And as you see, it did not respond with the message because it just changed the baud rate and that the data didn't get received properly. I can go and select that baud, reconnect. I'm going to select the first TTY USB 0, and connect, and work. And there's that. But anyways, Zeptoforth is specifically a multitasking forth, a preemptive multitasking forth. And here's a simple example of a multitasking in action. It's a very simple example where we have 3 tasks, a producer and 2 consumers. The 2 consumers are receiving on a rendezvous channel or an F-chan as in Zeptoforth's terms. And it's also using a lock to go and control access to the terminal. So I'm going to send the data across. And I'm going to do and here it's the producer task is consistently sending increments of 1 to both the consumers, which are then displaying the values and are not stepping on each other's toes with regards to the console access due to the lock. And as you can see, it uses something called with lock here, which takes an execution token and a lock and executes the execution token with the lock locked. And if an exception occurs, it'll unlock properly and then raise the exception. Okay, I'm actually gonna reboot at this point, but I have to disconnect because I changed the baud rate and set the baud rate back. And it's also specifically a priority scheduled multitasker. And here is a simple example that demonstrates priority scheduling in action. Where we go and do init tests. Oh, that's why I put in a module other than the fourth module. So I had to explicitly refer to the module or import the module. And the red numbers are being displayed by the high priority task, where the white numbers are being displayed by the low priority task. And the high priority task, while it's displaying its numbers, busy loops so that it keeps control of the processor. But when it's between those sections, it uses MS, which gives up control of the processor, allowing the low priority task to run. And of course, we're using a lock to protect access to the console in here. And what you can see here is using something. This is a do loop essentially, but it uses a execution token in many cases introduced with quotations rather than traditional do loop. Tell me if I'm going over. Give me a boot. I'm gonna switch to using my Raspberry Pi Pico, which if I don't have Mecrisp Stellaris installed on it, I'll go and demonstrate multiprocessing.
Travis, can we ask for questions to the group?
Sure.
Christian, do you have any questions for Travis? Christian likes very much the Zeptoforth, so I have no experience, but I trust him.
I would like to have questions, but right now they're just puzzling ideas in my mind. I've been puzzled by many of the concepts in there that are very computer science oriented, like the channels, and so
it's all everything, a lot of things that are new for you.
Yeah, but what I like is that Zeptoforth is aligned with a lot of the concepts that are taught in school in computer science. So it will allow many of the people with previous experience in computer science, with computer science training, to better understand Zeptoforth because it has some standard concepts. So I do like Zeptoforth a lot, but I will have to work a lot to understand a lot of those concepts. But thanks, Travis, for the nice work.
Excellent. Fantastic. Fantastic, Travis. Good presentation. Who else has any questions for Travis and Zeptoforth or his terminal, his new terminal? Albert van der Horst, probably.
I have just a remark. I just like the quotations or the square bracket semicolon things. I have used those things more and more, and I really like them. But I have no questions.
Or who else? Atle, you are very quiet today. Don Golding. Hello, Don. How are you? Any questions? Or
Hey,
Peter
gang.
Jakacki? Who else? Mateo. Pablo Reda. Pablo is also very quiet.
Cool work, Travis.
Thank you.
We have Holly from Taiwan also. Hello, Chang Luk. Holly, how are you? Geoff, you wanted to ask something about Zeptoforth? No? What are you trying? Mecrisp on the moment?
Yes, it's Mecrisp that I'm using at the moment. So I will get around to having a look at Zeptoforth eventually, but I'm getting used to one at a time. To easy steps.
One thing I should know is that Zeptocom.js is compatible with Mecrisp. The only but though is that it does not currently work with the tachyon features, because it relies upon recognizing Mecrisps OK message. And I hadn't got around to implementing tachyons because there's too, because of because there isn't a consistent prompt, because the prompt changes.
Yeah, the prompt displays the number of items on the stack, and whether you're in ROM space or in flash space.
Yes.
So the hash is always there.
I think the hash actually, if I recall correctly, I might be wrong about this, but all actually indicates with the current base. That the hash indicates that you're in decimal base.
Oh, that's right, yes.
Well, guys, if there is no more questions for Travis, our next speaker is Demitri Peinado. If Demitri, you are ready for your talk.
I am ready.
Fantastic.
Can you hear me?
Yes.
Good.
So Demitri will explain database for an expert system. Very interesting. So go ahead, Demitri.
Yes, thank you. Unfortunately, I'm on another device, so I have no camera, but I will be doing lots of screen sharing. So let me share my screen from now. If I can. Okay. And what I'll try to do is tell a bit of a story about how I started looking into this expert system thing. So some of you might remember when I presented before on a Prolog being implemented in Forth, and you may have seen my posts on the Facebook group. Now, the objective of this was to try and explore certain parts of artificial intelligence using Forth. So I worked on reviving this old implementation of Prolog in Forth, and I managed to get what was written in that paper to run. So I was pleased. And what the author had done is he had used Prolog to implement expert systems, right? So you have an expert system which is implemented in Prolog, which is implemented in Forth. And the advantage was, since Forth can run on devices with limited memory, you'd be able to have an expert system on your device. Now, for those who perhaps don't know about expert systems, it's one of the approaches of symbolic AI in the past. And the idea was that if you could put someone's knowledge into a computer and then guide a user through questions, it could be like having an expert working with an inexperienced user. So the computer has all the knowledge, it tells the user what to do and why it thinks certain things should be done and so on. One of the most common examples is actually for medicine in the medical world. Even as of recently, I had some pain in my ear. And I was like, well, this is bad. I need to go to a doctor. So I go on the app and I have to answer all these questions, right? Now, these questions don't get sent to a human because within seconds of filling out those questions, you get a response to say, you probably have this, and the reason we think that is blah, blah, blah. What you need to do is so and so, which is reasonably intelligent, right? So I thought, great. So I began looking into Prolog and expert systems, and this was the book that I refer to. I don't know if you can see that. Okay, building expert systems in Prolog. It's respected by many people, and it helped me to learn about these things. You know, you've got backwards chaining systems where you know what the result is going to be, such as with an illness. So, you know, common cold has certain symptoms, so you can identify it by the symptoms. But there's also another kind called forward chaining, where what you do is you don't know what the result is going to be like, but you have rules that guide the process. So say, for example, designing a PCB, printed circuit board design. Now, you can't say, based on these components, this is exactly how the result should look, but you know that the result is going to conform to certain rules. You know that there's going to need to be certain capacitors on certain pins. You know that certain tracks need spacing, and obviously you need to make sure that wires don't touch that shouldn't be touching. So that's a little bit of an overview of expert systems. Now, I was really sold on this idea until I got to the appendix, which I'm just scrolling to now if I can, and I saw the engine that was being used. So this is the engine written in Prolog for an expert system that is with the book. And what I can tell you basically is this uses some concepts in Prolog that are considered unclean, like the things that you're not really encouraged to do. I looked at this and I thought, I was expecting Prolog would allow you to construct an expert system more easily. I was a little bit disappointed. And so I looked at a tutorial from my teacher who's been teaching me Prolog. And again, first thing he's saying, use a domain-specific language. And he shows that, and it's not extremely hard, but it wasn't as simple as I expected. So then I said, well, why not just implement an expert system language in Forth? And that's what I did. And that's what I have on the left here, in Forth Win. And I will guide you through this to explain how this code works. It's very simple, right? It's actually very simple, the functionality. Some of the ways I've expressed things could be simplified, but we'll come back to that. So The resulting program looks like this, right? So ignore the first few lines, go to the database. Now, I understand that COVID-19 can be a bit of a sensitive issue for people. So please don't see this as a fact, or don't see this as a medical advice. It's just for illustration. I did use this when I became ill some months ago, and I actually was able to diagnose myself. But please, if you're unwell or have concerns, see a doctor. So what we have here is a language that I've created essentially in Forth. And what the system will do is ask you questions. Now, if the answer to those questions are yes, then you know the diagnosis. For example, COVID-19, the Delta variant, has these symptoms. COVID-19 Omicron has a different set of symptoms. And common cold has another set yet again. So I'll show you how you use it. All you do is you type in solve, and it, okay, that's because I haven't loaded the script. Let me just run that. I'm just double checking that everything is as I, yes, this should be correct. Okay, right, solve. And see, it starts asking you questions, okay? And all you got to do is answer those questions, and then you'll find out what you most likely have. Now, I actually did this, and so I'm just trying to find my record of when I filled it out. Yes, here we go. And so it asked me this, slow build of symptoms. Yes, it took a few days. Do I have headaches? Yep. Sore throat? Yes. Runny nose? Yes. Fever? My temperature's fine. I don't have a fever. Okay, no. Cough? Yes, I have a cough. Fatigue? Yes. Really, really tired. Tiredness? Yep, exactly. And congestion? Yes. And this was an interesting one. No loss of taste or smell. Because some variants have this, some don't. In my case, it was yes. And there you go. It tells you COVID-19 Omicron. So this is a simplified example, of course. It only has a few illnesses in the system, but for a hospital, this could contain, say, all of the most common kinds of colds, infections, and viruses. And you can automate some of the process, rather than the patient having to take up a doctor's time, they can fill in some answers here. The computer will then refer them to the right person. For those who are building robots and other things, this could be a system that a robot uses. The robot could be probing its environment, asking questions about it. Is there a wall here? Is there a wall there? And perhaps even the robot can diagnose something that's wrong with itself. So how does this work? What allows me to write in this language here, which doesn't even look like Forth? I mean, this looks more like Prolog than it does Forth. Well, let me show you. Simple expert system language. I define a constant, and then on the next line, you see the really, really key part. Create. Create is a word that allows you to basically define your own data types. I would say it's the version of data types or structures that is built into Forth. Of course, you can implement C-like structures in Forth as well, but create always exists in implementation, as far as I know. And what we do is we define in this word question. It's a data type. It's going to create something in a dictionary with 2 spaces. One is for the answer to the question, and the other is to say whether the question's been answered before. If a question has been answered before, we don't want to ask it again, because that's tedious. Why do this? You could have thousands of questions in your database. You want to be efficient. This here is just an accessor word. So I've kind of quickly formed my own struct. So this just says basically that this slot here is the one that contains the answer. So the one must say whether it's been answered before. And we define some other words too. So dot question prints out the question. It uses this word, which is forthwin specific, but there is usually a way to do it in your Forth implementation. What it will do is it will take the address of the question and it will find the word, okay? So say, for example, you pass it slow build of symptoms. You know, that goes on the stack. In fact, let me show you. That goes on the stack as an address, okay? But if I do word by address, it manages to find the words that corresponds to that address. So it's just a very easy way of implementing symbols, all right? This, I think, makes Forth as powerful as Lisp. So I'm very keen on this concept. This is just to interact with the user, asking them yes or no questions and updating the database. And after that, we get to the idea of rules. So again, you can see here a similar thing. I'm creating a data type called rule. A rule contains questions. Okay, so COVID-19 Delta is a rule. It contains questions, which are defined above. And essentially what the algorithm is, so notice here, I've even got a colon and a semicolon. I try to mimic the syntax of Forth, but I'm creating my own language. I'm not writing in Forth by the time I finish this. So the engine, the real engine of it starts here, and it's two very difficult to parse words. I'm looking at rewriting them because it doesn't have to be done this way. But the basic concept is this. When we prove a rule, what we're doing is we need to ask it. We need to ask each question, and when a question is answered no, we finish. Yeah, we stop asking questions because it means that this rule doesn't apply. So if you're identifying COVID-19 Delta and your answer to slow build of symptoms is no, well, then it's obviously not COVID-19 Delta, so it might as well move on to the next rule. This is expressed by this Boolean value. So you ask each of those questions until it gets to the end. It will give you a Boolean, yes or no. Did you prove it or did you not prove it? And then the layer on top of that is solve, which is essentially doing the same thing for each rule. So while prove asks the questions within a rule, solve is going through all the rules until it finds the rule that matches. And what I've done just before this meeting is I've experimented with creating this new word here, more rules, because it used to just say this, which is meaningless, but more rules make sense. If there's more rules and something else, then you want to prove each rule. Finally, when we get to the end, we give the answer, which is done by a little bit of arithmetic at the end, and using my favorite word by address word, and you type it out. So as you can see here, in how many lines is this? That's about maybe 15 lines, 10 or 15 lines. I'm just doing it at a glance. You can write a program that looks nothing like Forth. It's your own language to solve your problem. And what I'd expect from a user is that they would it's the database really that they would create for their program. And I actually did this because the original database was just an animal identification program. It just said, it asks questions and you identify, is it a duck? Is it a bird? Is it a snake? You know, that kind of thing. But I said, that's not a very practical example. So let me come up with something more practical. And so I rewrote the database, which is simply a case of adding the right questions and rules for different illnesses you can have. So that is my expert system. It is on GitHub. Here it is. So I will give you the link to this for anyone who's interested. If you are concerned about running it, you just want to run it. Again, if you just search for Forthwin, you can now have this Forth 2020 setup script. I'm on a new machine here. I ran this script and installed Forthwin just before the meeting. So it's very easy to do. You know, if you're new to Forth and you're testing this out, or you just run it without problems, go this way. If you're trying to port it to another system, feel free to get in contact with me, as like Francois did, and I will help you to implement this. So I understand I'm a bit running over on time, but just to give a final sort of comment, I'm looking to rewrite this, however, because I don't like the idea of iterating over some code and interpreting it. That's essentially what I've written an interpreter. I figured, why don't I just use colon? Colon does exactly that in Forth. So what I would do instead is I would make a question able to ask itself, which is what I'm experimenting here. So questions ask themselves, and all a rule would be is a colon definition, you know, rule Q1, Q2, Q3, and let Forth iterate through that list. This should simplify the program and make it easier to run on more devices. So stay tuned, because that's something I might attempt doing. And at this point, I'll open to questions.
Excellent, Demitri, fantastic.
Thank you very much.
I need to say that I used an expert system myself in the late 80s for the CNC machines. I detected that customers were asking all the time the same questions, first-time customers. And I implemented this also in Forth, but my system was huge, was not so well designed, so simply as Demitri did. I am very, very happy to see that. And also, this second part Demitri is explaining us is exactly what people should learn about Forth, that Forth is full of tools. And when you are clever, you can tweak these tools and have almost no code. Forth programs almost itself, but you need to be clever.
I would say it's the like sort of more advanced level of Forth, but when I say advanced, I'm only speaking from the perspective of all programming, right? As someone who's learning Forth, you can actually be introduced to this probably fairly early on and grasp it. But in terms of thinking this way, this is what I think makes Forth very different, and one of the reasons why I liked using it. I couldn't see myself creating a language like this in something else. I'd probably write an interpreter, but here I've not written an interpreter. I've just extended Forth. So
I propose something. This is extremely interesting for many points of view, for the group and also for the SVFIC members. Bill many times proposes challenge. And one of the challenges could be find uses for an expert system in force, because this is so small, this system is so small. Who knows? We can find lots of applications. Christian was talking on the chat about beers, how to select different kinds and brands of beers. There are many.
Yeah, so any knowledge that you have, you can encode, as long as for the system, as long as you can encode it in yes and no questions. There are some extensions you can do which make expert systems incredibly smart, where you have more options than yes or no. It has weighting to different things. So if somebody answers something wrong, the system still finds the right solution. But again, these are I want to present the basic, and then you see what you do with it. So try it. Even try it for debugging something. You know, if you find you run into the same problems again and again, and you have certain symptoms of that problem, say I don't know, your stack underflow, yeah, in Forth, you can write an expert system that asks you a question. Does your program do this? Does your program do that? And it can help you debug. So yeah, that'll be a suggestion from me.
What'd be interesting is on an embedded system, you have either flash or an SD card, and write this so it can go out there. And then maybe you can store some ASCII text out there, and maybe use some fuzzy logic on top of it. And just put the whole dictionary in there. Encyclopedia.
I mean, you essentially could, and systems, this isn't the first Forth expert system. You can do some research and find out more. But I think an AI called Psych, we talked about Psych, haven't we, Don? Is basically a huge database of common sense knowledge, absolutely massive. The difference, though, is it's interpreted. There's an interpreter that runs that, and you don't put this on embedded systems. This on embedded systems could be fascinating. It could help you debug appliances that stop working. It could be used in robotics. Imagine a robot has an issue, maybe it's stuck or something goes wrong. It can even run an expert system on itself. And
Demitri, as I told you, for machines, this is super important for machines.
Yes.
It was expert systems were born in locomotives. Locomotives. What is the name of that? I can't.
Steam trains.
Oh.
Yes, but repair for repairing locomotives, to finding.
Oh, I see. When something fails, what went wrong? Yeah.
They're repairing machines was like the first app.
And do you know that NASA created an expert system in Forth? And this was why they were so interested in Prolog, and why Prolog was implemented in Forth. It was for NASA.
Yeah, that was the Luadet's application. It was some experiments in space, and the expert system would guide them through the experiments and operate machinery, because there was fears that in that environment people might make mistakes. So yeah, it's been used by NASA.
Anybody out there remember an artificial intelligence database written in Forth called Savvy, SAVVY? It came out in the 90s. And they actually, I think it was one of the most famous robot companies. I don't know if it's UKIT or it was something like the Hero. They actually used it as kind of the robotic operating system for the robot. And it's very interesting. I would love to get some source code on it because it built an AI layer on top of Forth. Nobody's ever heard of Savvy?
Mm-hmm.
Really? Well, we're start building Savvy.
All right. Are there any other questions for Demitri? Good. So thank you very much again. And probably have a good follow-up on these things, and hope to see expert system related applications in the future. Right. So actually, we will now hear the talk from Klaus Schleisiek that we skipped in the beginning. So Klaus will talk about the microforce cross compiler and the microcore, which is the microcore assembler. And so, yeah, Klaus already sharing his slides. I'm curious, and please go ahead, Klaus. This is all
okay. Sorry for the late coming, but I made it eventually. So today I will talk about microforce, which is microcore's assembler and its interactive development environment. You know, at my last talk, some Japanese guy asked the question, what IDE do you use? And I didn't even understand the question. So now microforce is its own IDE, as if you are happy with a line-oriented thing. Again, you saw this picture, the design flow, and today I will talk about this green circle 2 modules, which are the force cross compiler and the debugger. Characteristics. It is a command line oriented IDE for microcore consisting of the microforce cross compiler. Then I will talk about how to compile forward branches, because that is special. It has libraries. It has a umbilical debugger with a disassembler and a single step tracer. It has a cooperative multitasker and semaphores, and I will talk about that because this is also innovative. It has a couple of mass instructions, or an extensive set to be correct, and it also has floating point. And if this doesn't answer all your questions, then please just refer to microforce.pdf, which is a full description of microforce on the GitHub, on GitHub. The links will come in the last slide. The microforce cross compiler. So microcore's assembler is a force dialect microforce. By the way, hopefully this is according to the most recent standard, but I'm not a standards expert, so I'm not sure. The cross compiler itself runs on a host PC, and only the runtime code will be produced on the target. The dictionary and the code that is only needed during compilation will remain on the host. So you always generate, let's say, optimal systems. The cross compiler does some peephole optimization. For instance, tail calls will be replaced by branches. When a load file is included, for instance, load core.fs, microforce is always loaded from source before compiling the application code. This sentence, I mean, this is normal for us force people, but I included this sentence for non-forces because to them, I mean, just look at Gen2. Gen2 died because this is just too slow. Well, in force, it's different. It's very fast. microforce loads on top of GForce 062, which is available as a Docker image. And the reason is that I had to make even a patch in GForce to realize the cross compiler in an elegant way, because deep in the heart of GForce there is an old bug that comes from Volksforce, and at the time I wrote Volksforce I thought this was a good idea, but then now it turned out that it was a bug, namely the way that the opening and closing brackets work. For instance, load core.fs. This is the load screen for the core test, which is something that I run every time I make any changes to the VHDL code. I include extensions. I include, this is an important line here. I include the architecture package.vhd file. So I get the, well, let's call it the current set of architecture constants also for the cross compiler. Then I load the cross compiler. And at that point here, we are ready to do real work. We now go into the target. We say this is a new target compilation. And this buzzword initialize means that all variables that we interactively assign a value to will be automatically included in the boot up code. So we can start immediately with initialized variables. Then I define the beginning of the code area. 9 trap address means we leave room for 9 software traps, which are all at the lowest end of the program memory. And the data origin is 0. We just start with an empty data memory. We include the constants which have been imported from architecture package. We include the debugger. We include a library. Now the library thing, I come to that later. The nice thing is this doesn't produce code, but if I use any word in the library, then the code will be compiled. And then I include core test, which is a test of all the instructions of microcore. As the last thing, this little board that I'm using, and I will, I will move the camera and give you an impression, of the board that I'm using. How do I get out here? Okay, there we go. So this is the little board that I'm. The camera displays things upside down, so this is difficult to get into focus. So this is the serial link to the host computer. This is the config. This is the JTAG dongle for configuring the FPGA, and this is power supply. And this is a Lattice XP28 FPGA, and with hardly any peripherals around it. Most pins are freely available. So that is my standard board that I'm experimenting with. Okay. So and well, you didn't see them because they were not lit. There are LEDs on the board, 8 LEDs, and I have made up this nice word init colon, and the init colon definitions are automatically included in the boot up code, and so I don't have to take care of the initialization in a complicated process. I always define an init when the time is ripe and I think of it, and that is all automatically assembled by this word initialization. Oops. Where am I? By this word initialization, which is here is a call, and the call means this is a forward reference because the code for initialization is actually built by the word end. And that does all the, I mean, what I have said here, initialized and the init stuff, that is all automatically included in the boot process. And then I define the boot process. I first erase all of the data memory. Why do I do this? In the past, I have made experiences by not initializing data memory, and I would debug code and everything works nicely. And then I go to bed and I switch off the board. And then the next morning I start the board again, and I want to be at the same place that I left the day before, and it doesn't work anymore because I made assumptions about the state of the data memory. And so the safest strategy against these pitfalls is to first erase everything to 0, and then this kind of thing cannot happen anymore. So I erase the data memory. I call the initialization. That means I initialize variables. I do all the init codes that I need. And then I switch into the debug service, which is calling the interactive debugger. And from this point on, the board and the FPGA and microcore is under full control of the host PC. But as you will see in a short while, I can control it absolutely interactively as we are used from Forth, as if the terminal would be connected to microcore. And then at the last thing, there are all the traps that are used, like the boot trap, the interrupt, the pause trap. Then we have a break instruction for the debugger, and that calls the debugger. Then we have do does, because the data memory is independent from the program memory. We need to do something to the data memory to get the do does working, and this is the actual code that do does executes. And this data store trap is used by the initialization code. It has the current dictionary pointer and a new number on the stack, and so this needs to be initialized, and so I do swap store cell plus to go to the next address. So that is the load screen, and now I will talk about the forward branches. This is really tricky, and it was an interesting problem because the branch offset of a branch, as I said in my previous talk, requires that the branch offset is laid down in the code before the actual branch. Plus, the branch offset may consist of one or multiple lit instructions. So if I have to leave space in the code, the number of bytes or unused or the space left may not be sufficient, so I have to recompile. So, and the strategy is that I took, it goes as follows. When an if or a while is compiled, an offset that fits into a single lit instruction is assumed. But not only the offset's address that has to be filled is pushed on the stack as usual, but also its source code location. Then later on, when the closing else then or repeat is encountered, its offset can be computed. Nice. And now we have two possible cases. If the offset is less than 64, we have to go back, so this is a negative offset. It fits into a single, no, I'm talking bullshit. If it is less than 63, it's fine for a single lit instruction and we are done. Otherwise, we now know how many lits will be needed, and the source code will be recompiled with a proper number of lit instructions in front of the branch. And this strategy works recursively, so we can nest ifs and ifs into begin whiles and whatnot, and this works nicely. The compiler sometimes goes in circles, but eventually the code will be fully compiled. And it is so fast, you don't really feel it. So it's definitely not enough to drink a cup of coffee in between. Libraries.
Can I ask a question?
Hello? Yes.
Yeah, can I ask a question? Going back to that screen, why is the offset so small? Why is it 63 or less?
If it is 63 or less, then we are fine with one lit instruction. Well, most if-thens are quite short, in my code at least. If it is longer than what?
So how wide is the storage unit? You're actually less than 8 bits. You're what? I don't know, 6 bits or something?
The storage unit, it's always bytes. We are talking about program memory, and that is completely independent from data memory. So we're talking about bytes, or to be more precise, we are talking about instructions, and instructions are 8 bits wide. And if we have only one lit instruction available, then the space for one lit instruction, then we can create numbers between 63 and -64. And if we use 2 lit instructions, I think we go from 8,100 something to -8,100 something, and so on. Clear? Dan, hello.
Oh yeah, I was nodding. Sorry.
I go on. I go about libraries. So the library forcelibfs will precompile forcelibfs as a library. This means it produces dictionary entries for each word definition in the library, but it doesn't compile code, it compiles pointers to the word's source code. And as I said, in this step, no code will be produced for the target. So I have all the words of the library in the dictionary, but not yet any code for the target. When later on a precompiled word is used, either during compilation or interactively, the word source code will be loaded and producing the actual target code. And therefore, never any dead code will be compiled. And so far, these libraries exist. Forcelib.fs, which are the most important force core word set words. Tasklib.fs, which includes all of the multitasking control words and the semaphore control words, and floatlib.fs, which is a floating point package. Alternatively, and that is the nice thing about libraries, they can be loaded using include forth lib.fs, and that will immediately compile all the target code as usual. So you have, with libraries, you have a choice of to compile everything immediately or on demand. The umbilical debugger. Host and target communicate via a two-wire RS-232 umbilical link in order to load microcore's program memory and to control microcore interactively via a terminal program on the host. And in the latter case, one has a look and feel of an interactively using a force system on the target system itself. Disassembler allows to inspect the compiled code using show word name. A single step tracer allows to observe the stack while executing a colon definition using trace word name. And after every step, the stack can be manipulated, or one of the following commands can be used. Nest to follow a call instruction, unnest to fall back into the calling word. After to continue single stepping behind a backward branch after finishing the loop, and jump to skip the next instruction for debugging purposes. You may find out that there is a wrong instruction in the instruction scheme, and so you can just jump over it if that is necessary. I think this is a proper time to come up with a little example. And here is the example, and here is my full screen. I go back, I show you I give you the full story. So here we are in my computer. I say GeForce. And then I say, for the heck of it, include load core.fs. So this loads the core test. And it tells me 3,370 instructions compiled. And then I can umbilical on. I can show you how the code is being loaded. I can say boot image, and then I see all the bytes that are shipped across the umbilical link. This is rather slow now, and the slowness has to do with the Zoom meeting, I believe. The CPU is stressed to its limit. So this goes on for 3,300 bytes. We have to wait. Okay, now we are done. I switch the umbilical off. Then the next thing is we have to synchronize the host and the target, and that is done by the word handshake, and it displays handshake. So now both systems are synchronized. They kind of know where they are. And now I can say debug. No, debug is not known. I have to, oops, yeah. Now you see the mCore prompt. We can do the core test, and it returns with a 0, which means everything is correct. If there is any number, I have the number, I can go into the source code and find which test failed. Above here, I have prepared a little example. With a call of do loop, which commas are fetch numbers into the dictionary. And here I pick up where we are in the dictionary. So I first say include, and please remember, we are already in the target, so to speak, virtually in the target. Include example.fs. It's include test.fs, sorry. So now we can say trace example. And it opens up a line. It tells us we are at address D32. There is the instruction 82, which is a lit instruction. And if I execute it, we have a 2 on the stack. I do a fetch. This address 2 was the DP. So here is now at 8. I push a 4 on the stack and I go into the do loop. And now I can say nest. And now you see that there are 2 greater signs. So I'm in the second nesting level, so to speak. And we see the code that the for generates, which is a 2R. And then we do the R fetch, we do a comma, which is a call itself. We go to Tor branch that has been compiled by next. Now we do another R fetch. We can now look what comma does. We nest into comma. And now we see, okay, we fetch the PC again, which is now at 9. We store the 3 at 9. So, and we advance the DP by 1. And we store the new value in 1, and then we exit. And now we are back at Tor branch. And now we might run through the loop again. Now we have 2 on the stack. We are at Tor branch and can say, "Alps, I know the loop works," I say after. And now the loop has been finished. And we encounter another exit. So we are now here. And we fall back into example with the exit. And now we are actually here about to execute the for, and we have another exit. And if we look at the stack, we have 4 and 8, which means and we can apply a dump to it. And so we see, okay, we have now comma 4, 3, 2, and 1 and 0 into the dictionary, because here is now at D, which is 8, 9, A, B, C. Now, here is now here. So that gave you a little impression of how the interactive debugging can work. With Pi, I'm back in the host computer. So much about the debugger. The multitasker. The scheduler is a linked list of task control blocks with a pointer to executable code that represents a task state. That means, we have, let's look at the terminal task, which is the one that does the debugging. The first field is the address of executable code, and that characterizes the terminal's state. And the next field is a link that points to the next task, and that field is a link that points to the next task. And so here you see we go in a circle, which is the well-known round-robin list. But then there is something above. It all starts with what I call priority. It does do priority and fills performance fields for me. And the most important number is always how many ticks did the longest running task consume up to now? Because if this number is, well, let's say about 2, 3, or 4, above, let's say 4, then I have to put another pause into this task code in order to get down with the task switching latency. So that is important for debugging purposes. And then comes a list of prioritized tasks. So P1. Whenever I have executed a task down in the round robin circle, I jump back in the schedule to priority, and then the first thing after filling the priority performance fields, I execute or I probe P1 whether it is ready to run, and if it is ready, I will definitely execute it. So this will always be the first one to be executed, and there may be a list of more than one prioritized tasks. And then I come to a little stub, which is the do robin link header, and I generate the round robin behavior of the forced multitasker by whenever the do robin goes ahead and advances the link pointer. So in one run, it points to terminal, and in the next run, it will point to T2. And then again, later on, it will point to terminal. So I actually mimic the running around in the circle and distributing the priority in an even fashion. And I found, I invented this when I did a data logger with very high sample rates. I found that I needed prioritized tasks in order to reach the real-time goals. So much about the multitasker. No, more about tasks. Task and semaphore. mCore allows for 2 by the power of tasks address width tasks using their own data and return stack areas. So I set task address width to 3, and so we have 8 sets of stacks available for tasks. Task name creates a task, and the words to control tasks are pause and hold and wake and stop and activate it, deactivate, schedule. Spawn is schedule combined with activate, cancel. That makes it's a deschedule basically. Poll and poll tmax. Now these are words that are not usually found in a forced multitasker. Sometimes a task waits for an event to happen before it wants to run again, and that may simply poll a flag whether this is set or not. And so this polling the flag in the exact field saves a lot of time, because I don't have to wake up the task, test the flag, and then put the task to sleep again. So this is for efficiency. And then poll tmax is even nicer. It combines the possibility of poll with a maximum time you give the poll, and then later on, I think it's a carry flag. On the carry flag, you will see whether the polling was finished because the condition occurred that you're waiting for, or whether the timeout had been reached. And so you can control in different manners to these 2 possible effects. Then we also have semaphores that have a name. And on semaphores, you have basically 4 control words, lock and unlock, which are used for mutual exclusion. So you can lock a semaphore, and then no other task can access it. And then you can unlock it again, and then another task has a chance to reserve the semaphore. And wait and signal is a counting semaphore, and that is used for synchronizing interrupts and tasks. So an interrupt may run and receive a character from a serial line, stuff it into a queue, and then it signals this to a semaphore, and the semaphore is incremented by 1. This means one more item is in the queue. If a second item appears in the queue, it is incremented again, and then the semaphore knows, okay, there are now 2 characters in the queue. And on the other side, the task that operates on the queue data executes a wait on the semaphore, and as long as the semaphore is at 0, the wait fails and the task will go to sleep. And once the semaphore has been signaled an event, then wait will go through, decrement the semaphore, and do whatever is needed. The task, because of the multiple stack areas, a task switch is very fast, and it takes about 7 full task switches. Means put the old task to sleep and wake the new task up and let it run again. Takes 7 microseconds on a 25 megahertz system. Mass instructions. Several instructions allow for the following mathematical functions when a hardware multiplier is present. And these are single or dual cycle instructions. times is a single cycle, times is a single cycle, and times itself is a dual cycle instruction, because first we do a times and then we throw away the most significant word on the stack. And there is a word in microcore that checks that there was no overflow. That means the sign bit of the second item on the stack has to be the same polarity as all the bits in the first in the top item on the stack. And if this is not true, then we have an overflow, and we cannot do the times instruction. It would give us an incomplete result. And then there are bit step instructions for divide mod, divide mod, square root, and logarithm dualis. Floating point. Floating point, microcore has a configurable data width. So there are not only 32-bit floating point numbers, but there are also 27-bit floating point numbers or 24-bit floating point numbers. So floating point numbers are data width wide, and therefore they can be handled on the data stack just like integers. And in microcore, we don't need a separate floating point stack, which is extremely nice, I find. The floating point exponent is x bits wide, so this is configurable. And therefore, the mantissa itself is data width minus exponent width wide. And in a 24-bit system, a 6-bit exponent and hence an 18-bit mantissa allows for meaningful floating point computations. I have tested this. I have prepared code on the host computer itself that I can say, okay, now behave like a 24-bit system, a 27-bit system, a 32-bit system. And on these systems, I have done tests on how stable the floating point is. And interestingly enough, 24-bit in a 24-bit system, you can do meaningful floating point computations. Usually, floating point I/O is responsible for about 70% of the code. And therefore, I have realized I/O in a completely unusual manner. I just handle integers. But on the floating point level, I have scaling operators, micro, milli, kilo, and mega available to scale my floating point number in such a way that I can get integers out in, well, these are called the engineering magnitudes. And since in microcore, I'm not interested in floating point IO on the display. I mean, what the heck? It doesn't make a lot of sense. But instead, I have to use, sometimes I have, like for instance, if you want to compute the temperature resistance relationship of an NTC resistors, you better use floating point because this includes the exponential or logarithmic function to do it one way. So from resistance to temperature, I believe you need the logarithm, and from temperature to resistance, you need the exponential function to do the computations. But with this approach, the floating point package on microcore is amazingly compact. It only takes 500 instructions, including exponential and logarithmic function. Oh yeah, this is, I see here. And microcore has been prepared for a few specialized floating point instructions, which are time critical, which is to float. That means a number pair consisting of mantissa and exponent is converted into a floating point number. The opposite, float from a floating point number, is split up into mantissa and exponent on the static. And normalize, the mantissa exponent is converted into an mantissa and exponent where the exponent uses its full width. And this is an interesting instruction because it is an auto-repeat instruction on microcore. So the normalize will run several times if I have to shift the mantissa several times, and it will only leave its automatical loop when the result is even normalized or the exponent is its maximum value, or is it the minimum value, whatever it is. So, and then the fourth special instruction is the fractional dot times dot instruction, which is used to compute the Horner scheme for transcendental functions. So floating. Oh, by the way, transcendental functions. My Bible, as far as these are concerned, so if you have several coefficients in order to get close to an exponential functions, you can use the Horner scheme. And my Bible to do that and to find the functions and coefficients is the book by Krüger, Publishing, Hart et al. And I can really recommend, it's expensive, but I can really recommend it. It gives you all the transcendental function and in different precisions that you will ever need. So links, microcore is available on Git, and its documentation is also on Git under documents. It has an overview, getting started, microcore.pdmf, which has all the hardware instructions, microcore instructions, which is a list of the instructions, microforth, which has all the words that are available in microforth, and the public license. So that's it. Questions?
Super, danke, Klaus.
Fantastic. Thank you. Yeah, are there any questions to Klaus? I think that's more a sign of overwhelming and of not being interested. Yeah, because it's so much detail and so many well thought out ideas.
A lot of information all together.
Yeah.
I think it's absolutely fabulous, Klaus, what you've done. It's amazing. Your system would be really great for embedded systems. really excellent.
Yeah, it's a productive environment. Definitely. I mean, on the last job I have been, they didn't know anything about force, but at least I was given the freedom to do whatever I wanted because I needed to hack together experimental circuits to do experiments with. And the only thing that people first wondered how fast this goes, later on they got used to it. And when they then were confronted with, after my retirement, with a guy that came after me, they kind of got a feeling for what the normal course of operations is. And unfortunately, the situation is still such that the management doesn't believe that this has anything to do with force. They just believe I was a genius programmer.
I have a little question. How do you handle priority inversion?
What do you mean by priority inversion?
Let's say you have a semaphore and you have one task that's holding the semaphore, a binary semaphore that is, that has a low priority. And then you have another task which tries to hold the semaphore, which is of a higher priority, but is waiting for the lower priority task to free up the semaphore. Like, I myself in Zeptoforth, I use an algorithm called priority inheritance, where when I have my low priority task, I temporarily give it the priority of the high priority task until it releases a lock. Do you do anything similar, or?
No, I have never, up to now, I have never run into such a situation that a semaphore was shared by a prioritized task and a lower priority task, because my philosophy is the priority task is woken up by interrupts with a signal wait mechanism. And so the interrupt does the saving the data, so to speak, and nothing else. And then the prioritized task does all the remaining processing that has to be done on the data, period. And the round robin tasks do ancillary things that don't have to do with this data stream. And I don't see, I mean, how I could do this. I mean, if a lower priority task got the semaphore, it has the semaphore, period. And then even a prioritized task would have to wait for the lower priority task to give it free again. And I don't see any way how you could get around, because once the lower priority task is across the semaphore, you don't know where it is and how much data it changes that also is of interest to the prioritized task. So I would say I wouldn't do that. I would avoid the situation.
I think the key word is avoid the situation.
Yeah.
Keep it simple, stupid. So when you're looking at your embedded system and you want to do this multitasking, you just have to architect it so you don't get into that situation. Yeah.
Right. Yeah. So being aware of the situation is important so that you can avoid it.
So if there are no more questions now, I would like to get feedback on whether I should give a talk on the VHDL code and structure for you. And if there are enough people, I can do that in the general meeting. If there are only very few people who are interested, we could perhaps set up a private Zoom meeting in our own group. So I'm prepared for these possible solutions.
Yeah, very interested, of course.
I'm interested too.
Yeah, so it's I
yeah,
think it's worthwhile.
Me too. Interest here.
Okay, I counted at least 4.
4 or 5, yeah, something like this. Christian is
Oh,
another
5.
one. And in the chat, another one.
And 6. And 6.
Yeah. So I think it's of general interest.
Yeah, you can count me in. It just took me a while to get to the expand button so I could unmute myself.
Yeah, and Brad as well.
Okay, so probably next month.
Yeah.
So
exactly.
this way, at least I will know what VHD is.
VHDL.
Yeah.
VHDL?
Yeah.
Yeah, it is a very verbose language, and you better be a 10-finger blind typist if you use VHDL. It's just a nuisance. But it does a job, and the synthesizers of today work reliably, and also the place and route tile tools for the FPGA. So, and VHDL has clear advantages over Verilog. I mean, in VHDL, you can define records which consist of several signals. And that makes your code a lot more readable and easier to maintain.
Yeah.
And that is something that Verilog doesn't have as a construct.
Right. So, are there any additional questions to Klaus? Well then, thank you again. And we're looking forward for a deep dive into the VHDL code at some future meeting. And our next speaker would have been François Laguel, if you look at the schedule, but he's not in the meeting anymore. And so he will probably as well give his talk next month, which concludes our today's meeting. And thank you everyone for participating, and I will just stop the recording